Welcome to Manchatmosphere. Today I'm going to have a chat with Professor Dave Schultz, who is a Professor of Synoptic Meteorology at the Centre for Atmospheric Science at the University of Manchester. Welcome to Manchatmosphere, Dave.
Thank you.
Professor Schultz will have the opportunity to respond to only 5 questions. So Dave, what aspects of atmospheric science are of interest to you?
Everything, really. I mean, I started out my career studying extratropical cyclones, so low pressure systems and fronts. And then after I got my PhD, I went to the National Severe Storms Laboratory in Oklahoma. And there my interest turned to convective storms. Then after that, I went to other jobs, including this one, where my interests have taken on much more breadth and depth, and now, you know, even worrying about paleoclimates and past Earths and just all along the way, just studying whatever is interesting to me, whether it's mammatus cloud formations or just even how peer review at journals works.
What specifically makes your research unique in your field?
Well, I like to think that the type of research that I do challenges what we see written in textbooks. So these are the books that we get as students in school or even as undergraduates or graduate students. And I would like to know that at the end of the day that my work has led to an improvement in what we see in these textbooks. So for instance, the work that came out of my master's thesis was related to the occlusion process of how these extratropical cyclones evolved, and that in itself now has got into many textbooks, and we're starting to rewrite the knowledge that have been previously written in these textbooks.
What methods do you employ to execute your research objectives?
The members of my research group, we start out pretty much always the same. What do we see in the observations? What do we see in the observations, and then how can we understand that? And so we'll start out looking at the observations, usually being motivated by that, seeing how far we can push those observations. But ultimately, the observations are imperfect, or we don't have the types of data that we need, it's incomplete. So we turn to numerical modeling, and I think that's where the power of science comes through. This is where we can run tests, try alternate scenarios, perform explicit calculations on the physical processes, and determine their relative importance.
Why is your research relevant in the wider world?
Why is it relevant? Well, I like to say that I don't make the forecasts, I make them better. And the type of research that we do is all about understanding those physical processes that operate in the atmosphere. Are they sufficiently resolved in models? Can models reproduce what we see? And if we discover some discrepancies there, this is where we pass this information on to people who develop models and say, okay, here's the challenge, make these models better.
Finally, I'd like you to give me one exciting fact about your atmospheric research.
One of the things that we discovered in our research was that there are about 30 or 40 tornadoes each year in the UK. And when you compare the density of those 30 or 40 tornadoes per year over an area the size of the UK, the density of those tornadoes averages out to be the same as across all the United States throughout the whole year. So there's actually as many tornadoes in the UK per unit area as function of time compared to the entire United States.
Well, thank you, Professor Dave Schultz. It's been a pleasure chatting to you on Manchatmosphere.
Thank you very much.